Now we come to the next topic. So it is called wedges. Wedges is that usually it is called this is called a wedge. By the way, wedge has a wedge, and of course in I think in just a bit of English, and in your mathematics, you know that this is this angle alpha. When alpha is smaller than 90 degrees, how do we say in Chinese? 锐角哈。那how about in English? Sharp. In mathematics, we will call it acute angle, and so it has a wedge that has an acute angle that is actually quite much more than 90 degrees. And if we have a force T pushing inwards, then the block A would be lifted. There is lifting. By the way, and also in the British English and British English, lift is equal to elevator in American English. Okay, so if you go to Singapore or Hong Kong, that a lift means an elevator. If we have a force P here going to the right and is moved inwards, that this surface moves up and block A is just lifting in block A. Now, if this force is removed, the friction on these two surfaces would not would stop wedge C and block A from falling. So there is no falling. It is called freestanding. And because there is friction on the between C and D and between A and C. So this is if you want to make A going down, that you need a force P to land block A coming down. But if there is no force here, no force P here, that it is freestanding. It will stay there. It's okay. So here in this kind of problem, we want to determine the P required to lift block A. And let's work on an example here. Let's work on sample problem 8.48. Now, a position of machine block B is adjusted by moving the wedge A. So if we put a force P to block A, that B will move upward. And we know that you can say this is weight of B, huh? And we know that the coefficient of static friction is 0.35 between all surfaces of contact, determine the force P required to raise block B. Determine is here, right? Determine the force P required to raise block B. Now, how to work on this problem? First of all, what is coefficient of static friction? It is mu S or mu K? Mu S, okay? Coefficient of static friction is mu S. Mu S is equal to 0.35. Now, and as I've mentioned in chapter 6, each rigid body has its own free body diagram. So we have two free body diagrams. So we have A and we have B. Oh, by the way, that there is contact and contact on the left and no contact on the right if it is unclear. Contact 是接触哈。So let's draw our free body diagram. What do we need to draw? First of all, that we draw the easy ones. Of course, we have P here. We have P from the right to the left. We have P from the right to the left, so we have P here. And we have 400 newtons going down here. That is the first thing. This is the easy thing that you can do. Now we come to the contact surfaces. How many contact surfaces do we have? We have between A and B. B and the wall on the left, and between A and the floor, okay? We have three contact surfaces. The most difficult thing in this problem is how to draw the free body diagram. Let me remind you. Now, let's do this one first. Let's work on this one first. So, if there is, of course, it is laid on the floor. So we have reaction force here. Let me mark it as M3 here. But we know that we have mu S equal to 0.35. So there is friction on this floor. So we have Fs here. Sorry, we have F3 here. We have F3 here. And what is the relationship between F3 and M3? Because before it moves, it needs to go to motion impending. So it will go to motion impending before it moves. So it needs to satisfy motion impending. So F3 is equal to mu s times N3. So what's the resultant of these two forces? It is R3. And what is the angle of R3 then? What's the angle of R3? Because F3 is equal to mu s times N3. So the angle of R3 here is equal to phi s, the angle of friction. Phi s is equal to arctangent of mu s. That is the angle of friction I set on the last page. So write it down first.